But as we try to go up in line screen, okay, in any flexo printing or any printing, okay, there's a potential for, yes, we get higher resolution, but then oftentimes things like dot gain and dot bridging and things like that become progressively a bigger problem as you go with finer line screens, and dot gain becomes more significant with finer line screens. Let's say, for instance, okay, everybody should know by now that when you print with flexography and you put a little bit of pressure, even if it's just kiss impression, if you look really closely at any of your images, you're going to see that little halo where the ink gets pressed around the edges. So if I talk about a 5 LPI dot that's 50% versus a 20 LPI image versus an 80, okay, if this dot as a 5 LPI image, okay, if it grows like slightly around here, gets just a little bit larger, it's not a significant growth here as it is on the 20. And definitely if I got a little bit of growth around here that went out even on my 5 LPI, that went out even like, turn my annotation on here. If around my 5 LPI, if I got a little bit of gain around here, and pardon my drawing here, if that gained a little bit around there, it's not going to be nearly as significant as if I looked at my 20 LPI growing. Okay? If I then looked at my 80 LPI, I might have dots that start bridging and touching, and the gain's a lot greater. Okay, so proportionally, as I go up in line screen, the amount of gain that I get is going to start being more significant. I'm going to notice it much more greatly because I've got a smaller dot. Okay, even though these are all 50% dots, when I get up to finer line screens, those are smaller dots. So the same amount of growth around the smaller 5 LPI versus the 80 LPI is going to be not as significant as these finer line screens. Okay? And when we start looking at overall tone curves from highlights to midtones to shadows, okay, oops. So when I start looking at the difference between what happens, even between highlight, midtones, and shadows, those finer line screens, it's going to be much more significant throughout the tone scale from highlight to midtones to shadows. Okay? So when we're printing properly and we start looking at our different possibilities as far as line screen, the finer our line screen is, the less noticeable this rosette pattern is. And we oftentimes talk about a moire being a bad thing, okay? And what we've got to realize that a rosette pattern is still a moire. It's just not it's the least objectionable, okay? Least noticeable moire, okay? So what we hope for is this nice little rosette pattern when we overlay, and if we're with a very coarse screen like this one here, this would be like us looking at a good quality image under magnification, that we would be happy if we saw this. But if this was a real coarse screen like 35 LPI or something, this would start being an interference pattern as far as like details that we're trying to capture with an image. So when we look at a true moire happening, that's where our screen angles aren't far enough apart. So when we only have, say, 8 degrees difference here between the two overlapping screens, okay, we get this weird grid pattern. And that's just that interference that's happening there, that we can't have screens that are just every 8th dot or something, you're getting dots that overlap each other by a certain amount, and that's where you get this pattern. So what our goal is with this rosette pattern is that we're seeing all these screens kind of like just rotate around one another. So you're seeing kind of dots repeating in this little circular kind of rosette pattern. Okay? So when we look at conventional screening, if we were just going to be doing screen angles for offset litho, we would probably just go with standard screen angles like this. But from having done your screen printing project in 207, 2070, you realize that not only did you have to deal with the different screen angles for your process color images for each one of your colors, you also had to place those in positives on your screen or image your screens where you didn't get a moire with the screen pattern. Okay? So the reason why we have a set of like some semi-standard screen angles for flexo would be because we don't want them to moire with analog scrolls. Okay? And most analog scrolls are engraved, and we'll get more into this when we talk a little bit more in detail about analog scrolls and engravings and things, and making selections about those and why we do certain things or specify certain things for analog scrolls. But traditionally, early on, one of the reasons why they went with these standard flexo screen angles was to prevent a moire with the analog scrolls, because the analog scrolls had these little cells on them that created a grid pattern, much like your screen mesh for screen printing in 2070 created a pattern that you had to avoid a moire with your positives in imaging them on your screens. If I picked up an image from my analog scroll, from a analog scroll that was engraved at 45 degrees, which is not as common anymore, but I would end up with my black printer for sure creating a moire pattern against my analog scroll engraving. Okay, so almost kind of just a fun fact at this point, but that was the reason why they traditionally changed those angles for flexo. We also do have to worry about, as far as screen angles, even now that most analog scrolls are engraved in a honeycomb pattern and they're like 60 degrees, we still want to be concerned about still getting moire patterns because of the line screen of our analog scrolls, okay? How many cells per inch they have versus how many LPI we have in our images that we can still get those moire patterns. So it's still significant. It's still something we need to think about as far as screening images, and that we don't just willy-nilly just choose random screens and screen angles or LPIs. We actually have some basis for what our press is capable of or what our inputs are at press time that will impact our choices and selections on pre-press. So another type of screening that we used to see a lot of, especially direct print corrugated, was they tried to avoid issues with moire, and they also tried to reduce the problems of where highlight dots became a big problem because they would just drop out and you'd have these big hard harsh lines or non-existent dots in your highlights. They moved over to using FM screening, which is frequency modulated, meaning all the dots are the same size. So the dots here are the same size, the dots down in the shadow end are the same size, but what you're doing is changing the frequency of how many dots are in a given area. So these remain all the same size. So in choosing an FM screen, you would need to choose the size spot, okay, which is measured in microns. That's that funny looking little U down there with the M next to it, okay, where we are specifying that dot size in microns. So in this case, you're changing the frequency of the dots. So to make a tone darker, you're just putting more of those same size spots into darker areas. So this resolved a lot, although once you got past like the highlight area down into midtones, it started looking weird and you had kind of this snaky looking pattern still showing up in there. Okay? So even though it's randomized and you randomize it for all your colors, it still had kind of a weird look to some of your large tone areas, or gradients would look kind of weird, or something like a big like blue sky with no clouds would look really grainy and kind of weird looking. So to get something that worked a little better, they moved to some more advanced screening. So when we move out of doing just AM screening or FM screening, they call it XM screening, and or full HD or hybrid screening. So in this case, you don't have just one or the other, you're actually combining the two. So when I look here at a gradient here, I've got in the shadow where that gradually comes back in and uses the XM screening there or the FM screening there, and the FM screening in the highlights. Okay? So this is just to try and avoid that harsh drop off of dots of all of a sudden you got this big dot to white and you see a hard break there. Okay? So XM screening is typically what you see most oftentimes used now in imaging plates for flexography. But again, a lot of this has to do with what kind of printing you're doing. So you might be perfectly fine to do AM screening and finer line screens on a narrow web, tag and label printing press for flexo, and then you might move to printing wide web, wide format, and you might use something like this XM screening, and being able to use a fairly fine micron spot size. But then you might move on to something like corrugated, and you might have to print such a large dot in any kind of XM screening like this that you might just run into some really bizarre looking images. With a lot of our software, we actually can do object-based screening. And we'll get more into that when we start looking at how we utilize some of the software to actually manipulate our images that we've created, whether that's text, whether that's line art, whether that's gradients, screen tints, overlapping screen tints, or if we're talking about process color images or halftone images, we can actually apply object-based screening. So in that case, we could actually change what we have applied to one part of our image. We could have one image, say a process image in there that had this XM screening applied to it and different dot angles and screen angles applied to it. Or we could have something else that was another LPI and AM screening. So we're not stuck with just doing one thing overall in the whole job. So we could approach each different type of image a little bit differently into successfully creating a really good quality flexo job. So we've come a long way since when I was a kid in graphics, that's for sure. So just kind of giving you a side-by-side comparison here of AM screening versus FM screening versus a hybrid screening versus another type, HD screening, where they've got the actual dots that print, and then they have some little support dots that don't print. And we'll get more into that later, but these are only here to help stabilize these other dots. Okay?